Mr. Uday Dixit. He is the project manager for automated inspection systems at Carl Zeiss India Private Limited. He has an experience of more than 26 years in sales and marketing of capital goods, especially in measurement and inspection systems. Mr. Uday was also on assignment in Zeiss headquarter, Germany for a year. Today, Mr. Uday Dixit will give us a brief view on automated inspection solutions for sheet metal parts. So, delegates, let's welcome Mr. Uday.
There are many options available when you want to inspect a sheet metal part. You can have 100% inspection inline or a sample inspection at line, a little high precision in offline. Also, how you can inspect a surface, automatically, and we will summarize. First topic, inline inspection system. I will just run a small video here. Most of the examples are here the car body, which is a major application, but it can be employed for other applications such as aerospace or white good manufacturing. Here the part comes on a conveyor after going through several operations, and the sensors mounted on a robot basically looks for all the positions, whether the slot is in right position, nut is welded in the right position, if the hole is drilled or not, if there is any missing operation, everything is checked before it goes for a final assembly or painting. So each and every part can be checked here like this, and there are many types of sensors available for such kind of application in this AI. So there are laser sensors available, there are optical sensors available, there are grayscale sensors available, there are fixed sensors available. There are very special sensors available also to check the gap between the transparent parts and the sheet metal part, like a headlamp or a tail lamp. So there are many options available for such applications. This is really advanced technology, what we call is a correlation-free measurement. Normally what happens when you employ inline inspection system, the whole system has to be correlated with some high precision measuring instrument. The reading should be correlated so that all the measurement results are very reliable. So nowadays there is a new technology called correlation free technology. Here there are cameras mounted on a frame. They monitor the movement of the robot, and you have a very high precision measurement right from the first part. No more correlation required with any other machines. Moving to the second topic, at line. If you don't want 100% inspection in line, you can build a small cell next to a manufacturing line or assembly line. You can still employ a rebo here. You can load the parts from the various sides like this. You can have a very wide variety of the parts, loading and unloading with an automated conveyor or a manual loading system. And since this is a robot based, then it's completely flexible. It can accommodate any changes very quickly, and you have less dependency on, say, manual picturing inspection or manual inspection. Moving on to the third topic, also offline inspection systems are available with a coordinate measuring machine, which are popularly known as horizontal arm measuring machine. In short, it is a ham. Normally, it takes very, very long to measure precisely under such circumstances. But we have a very special sensors here. As you can see, it can go from inside and from inside. It can go to various corners and quickly scan the part. We are able to save time up to almost 80 to 85% compared to the conventional probing technology. Moving on to the last part, surface inspection systems. Yes, when a car body is manufactured, before it goes for painting, it normally check for all kinds of defect manually. Similarly, it is for white good manufacturing. In aerospace also, sometimes there is no damage is allowed. So how do we check this defects? Because in the normal process, they are not visible. And after we coat it, some defects are visible. After we paint it, most of the defects are very clearly visible. Classic inspection methods are, we normally employ oiling, or you put a manual inspection. You can grind with the stones, and some skilled operators are able to find out the defect. Also, some operators are able to peel it with a cotton gloves with their lot of experience. But these are all judgmental. There is no digital data available, and this is highly subjective. You are highly dependent on the skill of the operator, and it is important that you identify or you find out this defect early in your process to save your cost, so that the wrong part doesn't go to the next operation. So how do we? There are many types of defects you want to check. Bumps, dents, sink marks, waviness, draw lines, making. In other words, you thinning one step before cracks. Crack is, of course, the biggest damage you can have. So there are very special sensors available which can be mounted on a robot. In our case, it is called ABIS2 system, and this can check the whole surface in seconds, and you can have all the identification of the defects very automatically. You can have an offline session like this here, or you can also have an inline session. I have one video from the Mercedes. Yeah, this is a classical, traditional method of judging the defects manually. Volkswagen team had prepared this video to find out the advantages of having an automated inspection system. Here we keep the part, roughly align it with the laser pointers, and just run the program, and you can see how many seconds it takes to scan the whole door, and all the defects are superimposed on a CAD model with a required degree of the defects, and complete digital output is available. You are not depending on the judgment of any operator. So in the whole process of sheet metal manufacturing process, we have a solution for the inspection, whether it's completely automated or semi-automated, or inline or offline or at line, or whether it's a tool making, whether it's a press shop, whether it's a weld shop, before painting, after painting. At various stages, inspection solutions are available, including the fixturing systems, and everything can also be, since the digital output is available, you can have a complete control on the process. In the Industry 4.0 or a smart factory, whatever process you want to adopt, it's possible to have. So that's it from my side.